So here's the stairways that I ran up. I'm going to count the stairs. 1, 2, 3, 4, 5, 6, 7. Turn the corner, here's 8, and then 9, 10, 11, 12, 13, 14, 15 stairs. So I'm running up the stairs. I hit start on the stopwatch camera, and then I ran up the stairs. And when I got to the top, I hit stop, and there's my time. Here are the calculations to my horsepower lab. First, my prediction was that I'd go half a horsepower. I could produce half a horsepower for a short time, that being less than 10 seconds. I showed here that power is work divided by time, and I want to make sure I'm in metric units of watts, joules, and seconds. The calculation for work is force times distance, and work is when I change an object, either its position, shape, or temperature. And here I'm going to use the units of joules for work and then newtons and meters for force and distance. I'm going to need to calculate how much force it takes to lift something. And here the force to lift something is the object's weight, which depends on the acceleration of gravity and its mass. And the formula for that is going to be the lifting force is going to be the mass times 9.8, which is the acceleration of gravity on Earth. And that'll give me a force in newtons as long as my mass is in kilograms. I'm going to have to convert pounds to kilograms, and so I looked up here, and I know that 1 kilogram is the same as 2.2 pounds. And then I'm going to convert from my power into horsepower to compare to things I'm familiar with, like cars, chainsaws, and all of that. So 1 horsepower is equal to 746 watts. When I did this lab, here are my calculations. First, I had to find the distance that I was running up, the vertical distance. So I measured the height of each stairs and counted the stairs. When I did the math to figure that out, I had 15 stairs times 7 inches for each stair, and then I'd multiply that by 0.0254 meters, because that's how many meters are in 1 inch. And then I got a vertical height of 2.667 meters. Then I had to find my mass, so I took my weight of 210 pounds and I divided by 2.2 pounds, or 2.2, that'll change that to kilograms, and I showed here that the pounds cancel out, and I have kilograms. Then with kilograms I can find the lifting force, so I can take my mass and multiply by 9.8, and that gave me a lifting force, which is the same as the force of gravity, of 935 newtons. Then I could calculate my work. Work was force times distance, so I had to multiply the number of newtons it took for me to lift myself up, and multiply that by the vertical distance I traveled up, and I got 2,494.869 joules. Once I knew how much work I did, I could find my power. So power is work divided by time. So I took the joules that I did in work and divided by 6.76 seconds, which was the time it took for me to run up the stairs. And that gave me 369 watts. Once I had that, I could convert to power by dividing by 746, because 1 horsepower is the same as 746. And the way I wrote it here with the conversion factor shows how the watts cancel out. And that gave me a little bit less than half a horsepower. So my conclusion here is when I ran up the stairs, my power was almost half of a horsepower. For a short time, I was as powerful as 1/2 of a horse. To find my horsepower, I had to find my power in watts. This meant that I had to convert my measurements to the metric system and use the metric units for distance, meters, mass, kilograms, work, joules, and time, seconds, to get power in watts.